Hello and welcome to today's KEB Tech Tuesday web seminar about COMBIVERT S6 application inverters and Servo Drives for your automation. We are happy that you logged in today. My name is Tobias Wenneker and I'm working the product management at KEB. If you have got any questions during the webinar, please feel free to ask these questions in the webinar chat. Now I hand over to my colleague Stefan.
Yeah, also from my side, welcome to our webinar. My name is Stefan Höltke. I'm also product manager at KEB, and we will now change to our presentation. So I hope you can see our presentation and I hope you can hear us. We will now change, I will now change to the first slide. I hope also you can see that. Yeah, what is our topic today? To start, we want to introduce KEB Automation a little bit, who we are, what we do, and also give you a short portfolio overview. After that, we'll change to the main topic of today, the presentation of the products COMBIVERT S6 and F6, a short introduction, an overview, demonstrates the flexibility, different communication possibilities, and at the end, we will want to focus on performance and some features. If this has been done, and after a small conclusion, we want to respond to your questions. So who is KEB? KEB is an independent, family-owned, medium-sized company founded in 1972 by Karl Ernst Brinkmann, starting with electromagnetic brakes and clutches. Since 35 years about, we started with developing and producing drives, inverters. Our main plant is in Bahntrup in the center of Germany. There we do development and production of inverters and clutches and brakes. In Eastern Germany, in Schneeberg, we have got a gear motor factory where we produce and develop gear motors. And then abroad, there are further plants like in China, in Shanghai, and in the US, in Minneapolis, where we do assembly of inverters and production of clutches and brakes for the local markets. Besides that, of course, we have sales locations throughout Germany, Europe, and also worldwide. So on the page, you can see the number of products we produce per year. In general, we have a very high vertical range of manufacturing. This applies for gear motors and for electromagnetic production, as well as to our inverter production. Like we do a metal processing manufacturing, for example, for the heat sinks by ourselves. We have a SMD assembly line, THT mounting, assembling lines for the drives, of course. Then we do inspection and test facilities at component assembly and device level. And we do a high effort on quality assurance in the production, but already also in the development process. Except for the mentioned final assemblies, productions in China and the US for the local markets, all our drives are made in Germany. On the picture, this is not a production plant. This is our sales location in southern Germany. So now you can see a part of our portfolio. One of our strengths are system solutions, from brakes to EcoCloud, let's say. So some examples for control and automation you can see in the upper side of the slide. Product range is IPCs or RIPCs, embedded controls, safety controls, also HMIs. We also offer routers for remote maintenance and other control and automation components, and as well services, of course. The product range drives in the middle of the slide. We offer controlled and regulated drive controllers from 370 watts up to 900 kilowatt in the 200 volt, 400 volt, and 190 volt range. Multi-axis systems, supply and regenerative systems for blockwise and as well as sinusoidal supply and regeneration. AICs, active in-feed inverters, and also, of course, EMC filter technology, which is also partly produced here and also developed here in Germany. For our product range of motors and gears, we can supply gear motors with asynchronous machines as well as with synchronous machines like helical gearboxes or bevel gearboxes. Without gear, we offer standard synchronous motors as well as high torque motors for slow speed applications. Our product range for magnet technology, you can find electromagnetic clutches and brakes for industrial applications. Besides that, we have some application-specific product ranges. For example, customer-specific magnet systems for vehicles, drive system for electric auxiliary drives in vehicles, and also drive systems for pitch and yaw adjustment in wind turbines, just as some examples. So now coming to the product, the main target for today. As already mentioned, we develop and produce drives since about 35 years now. So F6 and S6 is our 6th or 7th generation, depends a little bit how you count. Both are all-round inverters, extremely flexible to use. You can use them for simple V2F applications as well as for servo drives applications. You can use them for high-speed applications as well as for high-torque applications with low speed. It's usable with different kind of encoders, but also encoderless vector controlled with different motors, different field buses, so very flexible system. The power range is up to 450 kilowatt in the moment. S6 is designed as a classical servo driver and goes up to 7.5 kilowatt. 2 housing sizes are available there. And F6 is more designed as a classical inverter, starts from 4 kilowatt up to 450 kilowatt and in 7 housing sizes in the moment. Yeah, and especially F6 has got a very compact design, especially in the medium and the high power range. In performance and functionality, both devices, F6 and S6, are equal. So one of our core competencies are different kind of cooling possibilities. Also this we're offering now in the 3rd generation. You can get the F6 in as a push-through variant, so cooling outside of the cabinet, but also in the inbuilt variant inside of the cabinet, as well as liquid-cooled and air-cooled. So the push-through variants are IP54 at the backside. The liquid-cooled are equipped with stainless steel pipes, and it can also be equipped with braking resistors mounted on the cooling part. Software-wise, where there's a software functionality inside of the drives which can do the liquid cooling management, so which can control a valve, for example. This is available for the drive cooling, but also it can be done for a liquid-cooled motor, for example. Yeah, in which application can you use COMBIVERT S6 and F6? One of our main businesses is plastic machinery, for example, extruders, injection molding machines, but also woodworking, especially for spindles, milling, sawing, drilling, and also CNC applications, also for metal machining in that case. Then we use them in passenger elevators, in intralogistic like storage retrieval system, construction cranes. It can be used in textile machines, including ring spin machines or weaving machines, compressors, packaging machines, test benches, and many, many others. So you can see it's versatile in use. And yeah, versatile is a keyword for me to pass over to Tobias.
Okay, Stefan, thanks for this introduction of the COMBIVERT S6 and F6 products. Yeah, let's speak about the functionalities for the scalable motor control management. The drive software is able to run 4 different motor technologies: the classic asynchronous motors, the dynamic servo motors, and the newer technologies like APM and synchronous reluctance motors. Of course, there are different control algorithms inside the software. For example, the classical V2F mode, and for the other parts, the closed loop with encoder or the closed loop without encoder is also possible with this COMBIVERT S6 and F6 drive controllers. The next page, I would like to give you an overview about the closed loop control without encoder for the asynchronous motors. We call this ASCL, and the basic information like rated frequency, rated speed, or rated current has to be entered for the type plate data inside the COMBIVIS software, our tool or handling tool to put some data inside the drive. And at the end, the identification of the extended equivalent circuit diagram data will be handled by the software ASCL itself inside the drive. This control mode is based on an image of the motor data and the measured drive controller output current. And the output filter technology like motor chokes or sine wave filters can be easily integrated into the motor model. On the right, you see some features of the ASCL. We extended these new features, or we extended the feature in general of the ASCL optimization for a fantastic motor rotation and smaller speed, and the other features to have a good quality in the total speed range. This was a new feature of the ASCL control mode. The next page is about the closed loop without encoder for the synchronous motors. It's similar to the ASCL, but of course it's not equal to this. Based on a motor image of the motor and the identification of the current measured by the drive controller, the motor models calculate the speed, for example, and the actual status of the rotor. Especially high-speed applications with filter technology are often equipped with KEB filter technology due to the motor characteristics. The features of STL are split into some sections on the right. We at KEB, we are proud to offer our customers encoderless positioning with a fantastic performance. If you have got any questions about this special performance, please get in touch with us to find a solution for your application. The next page is about closed loop with encoder. At first, it's a multi-encoder functionality of drive controller with the listed encoder types, like incremental or resolver, for example. The physical structure is realized with a fantastic ZUBD interface and pre-assembled cables with different cable links and are available for our motor portfolio. You can run at this drive controllers the possibilities of absolute encoder or non-absolute encoders. At this page, I would like to talk about scalable performance. Scalable performance, what's behind this message? The evaluation of application requirements for the drive controller could be done with our application team, and KEB supports you in the drive controller selection as well as in the questions of the performance topics. Which field bus do you like to use, or a standalone operation? How should the drive control loop be set up within the application? For example, the switching frequency, which is available up to 16 kHz. We will find a suitable solution for your application. The two drive controllers support the device profile CIA402, which shows the following operating modes: cycling communication via PLC control, or operating modes with PLC control or without PLC control. The classical standalone operation with digital inputs is also possible. Now I will show these two operating modes in two application examples to get in touch with these two different possibilities. The first application example is about the internal drive controller function. For example, at first, the jog mode with the motor POTI function for easy and fast speed configuration during the process is running, for example, change a speed or a torque, whatever, or emergency operation to move the machine if the bus communication breaks down. This was the jog mode with motor POTI function. The second example is positioning with internal up to 32 positions and speeds. The process changes by adjustable conditions transform the drive controller of KEB into a small PLC. This is a position mode, profile position mode. The last example for the standalone operation is the receipt management for smart application management. You can load internal settings such as acceleration times, target speed, or speed controller settings via digital inputs or by bus to the drive controller. The different motor types can be configured quickly and easily. Keyword in this case, multi-motor, one drive. The next page shows the interaction between controllers and drive controller. In this case, the box IPC is a master in the application and takes over the control task. The controller sends and receives set and actual values to the drive controller via the fast Ethercat field bus communication. Cycling means in this case that the master and the slave exchange the data in the same clock cycle. The physical motion at the end on the motor belongs to the profile which we sent from the master. The drive controller works depending on the operation modes in speed mode, for example, or torque-based. Safety tasks can be realized with a safety over Ethercat channel called FSOE. In this case, you see the FSOE communication is ready with the Ethercat communication, and the functional safety part is handled without the digital IOs, just over the FSOE part. Yeah, this is the word for my colleague Stefan.
Yeah, thanks, Tobias. So FSOE, this brings us to the scalable safety technology, which is integrated in the drive. In general, all drives are equipped with STO. Another function which is available is SBC, safe brake control. Besides that, there are various speed and position depending safety functions which you can see on this page, like safe limited speed, like safe limited position, and many others. Speed depending safety functions with encoder are possible, but also without encoder, which means for some applications, speed depending safety functions like SLS can be used without using a safe encoder. Encoderless speed dependent functions can be used in applications up to PLD and ZIL2, all others with encoder and STO and SBC up to PLE and ZIL3. The safe field bus, as already mentioned, is safety over Ethercat FSOE. This allows the use of all safety functions without external wiring. But, of course, there can be a mixed operation with FSOE, and also safe digital inputs are possible, because if you have an end switch, it can be connected in parallel. Yeah, here you can see the encoderless safety functions as well, a wide range of safety functions. In general, STO and SBC can be combined in one function. It's also possible to activate more than one safety function with one digital input. For example, safe limited speed and safe limited acceleration can be used together. For many functions like SS1 or SDLC, up to 8 data sets can be stored. That means, for example, if there is a handling system moving with shortened over travel ways, and that should use safe limited speed, then you may need certain safe speed for maximum speed or for operation speed. Then you may need another maximum speed for the reduced speed in the over travel way when you're entering this. And it can be different when you're leaving it, because then you can maybe be faster. Then retraction by hand can be another limit which is necessary, and a certain setup mode can be the fifth limit. So as you see, this is very flexible to use. Up to 8 data sets can be stored. All the sensorless functions can be used with induction machines, synchronous servo machines, and also synchronous selectance machines. The tripping time is very fast. It's below 3 milliseconds, which is fast for a safety tripping time. Available for the complete S6 and F6 power range are these safety functions. Yeah, coming from safety to motion control. On this slide, you can see a selection of software functionalities which are integrated in the drive. This represents the possibilities or the lethality. I took 3 examples out of it, and which I want to show you a little bit deeper. First example is the power off function. How to explain this? I think the best way to explain it is an example. Is if there is a ring spinning machine and it's working on the network, and there's a short supply voltage drop. Under normal circumstances, the drive would trip in under voltage error and the motor would stop uncontrolled. And in this case, on these machines, that would mean that all the yarns would break at the spinning points and hundreds of yarns would have to be tied up again. And this is normally or usually done by hand. To avoid this case, the power off function can be used. The inverter detects power failure in that case and automatically synchronizes the drives to reduce the yarn breakage. If you think about it, many other applications are possible, or this function is also useful for many other applications. Yeah, another example of software functions integrated inside of the drive. KEB, COMBIVERT, S6 and F6 are able to operate high-speed motors up to 2000 Hertz, for example, spindle motors. This can be used for synchronous machines and also inductance machines. It can be used with and without encoder. Of course, you need to take care about limiting frequencies if you use an encoder of the encoder itself. We support you with the dimensioning in this case, because it can be tricky. And of course, we also offer accessories for this: sinusoidals, filters, chokes, and so on. Maybe in opposite to high speed, there is high torque, which can be solved with the same drives. High torque motors on extruders, for examples. That means slow running machines with high number of poles and high torque. An example I had in the past, 40 pole motor with 255 RPM and 45,000 Newton meters, that also can be used or can be solved with these drives. So, and the third example, the internal servo pump controller. In this case, F6 drives operates a synchronous machine or an induction machine, which is mechanically coupled with a hydraulic pump. The F6 regulates the motor or pump in order to adjust the oil quantity or the pressure, the hydraulic pressure, according to the demands of the coming from the controller. This can be done very high dynamic, like in an induction molding machine. And yeah, the general advantages of these solutions are a high energy saving. That means less losses, and because of less losses, cooling capacity in the hydraulic system can be reduced or sized smaller. And yeah, also the lifetime of the hydraulic components can be longer. Yeah, also this software function includes an internal pump protection. yeah, to save the pumps. And also we have a wizard in our COMBIVERT operating tool for commissioning and to set up this function quite easy. And yeah, before I hand over to Tobias, all these examples have been developed together with customers. And this is also one of our strengths, developing solutions together with customers. So you're welcome to contact us. We are always like to help you.
Okay, thanks, Stefan. So in the next pages, I will give you an introduction of our communication tools. COMBIVERT 6 is the drive controller handling tool. It's a free of charge tool. And in addition to the standard functionalities, the startup wizard is a highlight of this software. Of course, the servo pump wizard, but even some other functionalities of the wizard structure are given by the COMBIVERT 6 software for an easy startup of asynchronous motors and synchronous motors, or to activate some error levels or some other identification alarms. Further COMBIVERT tools are for the control and automation sector. We call it Combivil Studio. This is an engineering tool for configuration and programming. And we have got soft motion according to the PLC open standard available in this Combivil Studio tool, and CAM and CNC functionality. Further software possibilities in the Combivil area are Combivil Studio 6 Safety, Combivil Studio HMI, Combivil HMI Mobile, and for remote access to the drive controller or to the complete KEB solution is Combivil Connect. This page shows you the Combivil Mobile. This is a smart connection to the drive controller. Highlights are, for example, the dashboard with configurable parameter for your favorite parameters, and parameter list management for easy exchange of parameter lists in service cases. This mobile app is available for Android and for iOS. Today's last topic is current trends in drive technology and drive controllers. Currently and in the future, we are focused on the listed 3 topics, and of course, continuously extended by us and our customers. High performance of sensorless safety technology in drive controller, like we mentioned during the presentation, with our sensorless safety technology in our S6 and F6 KEB drive controllers. The second point in our point of view is the smart communication to our drive controller with KEB Combivil Connect or KEB Combivil Mobile. Especially the last point offers us unexpected possibilities in the future. KEB is working on this topic in various working groups and projects to be up to date with the latest trends in the automation sector. Especially the IIoT is a trend of the complete KEB technology right now and of course in the future. Let us summarize briefly and short. The drive controllers of KEB Combivil S6 are extremely flexible, highly communicative, and of course powerful. Many thanks advance so far. So we are at the end of our presentation and we have a look in the questions in the chat.
Yeah, there's one question. Can KEB supply motors with safety encoders? With what type of encoders? Yeah, we can supply synchronous machines with safety encoders, with resolvers or sine-cosine encoders. These are the types we are supporting in the moment. There is one other question. It's about safety and high speed. Is it also possible to use encoderless safety with high speed machines? Yeah, this is also possible.
Yep.
We can go up with encoderless safety also up to 2000 Hertz output frequency. Okay. I think that's all.
Yeah, it's done so far. So many thanks for listening for this KEB Tech Tuesday web seminar. And if you have got further questions,
Contact us, please.
Please contact us.
Thank you very much.
Thank you.
Bye-bye.
Goodbye.